All right, this is our mini lesson for AP Calc. That's for Monday, March 30th. Today we're going to continue our work with substitution. This time we're going to start simplifying a function before we start integrating it with substitution. So I wanted to remind you guys of some of the properties of exponents and some derivative identities that are going to help you with today's lesson. One thing to remember is this one. When I have something like the cube root of x squared, that is going to be the same as x to the 2 over 3, right? All right, and then another thing is we know the derivative of e to the x is e to the x, but sometimes it's going to be another, like a monomial function. So it'll be, for example, the derivative of e to the 3x, we're going to say is e to the 3x. And then we take the derivative of 3x. So the derivative of 3x is 3. So it would be 3e to the 3x. Okay, you have to know this for today's lesson as well. Okay, so let's get on with the mini lesson. I have a couple of examples. And in both of these, you have to work with exponents and then find the integral using substitution. So for the first one, we've got 2x over 1 plus 2x squared to the third. So I'm going to let u be 1 plus x squared. And my derivative of u is, well, the derivative of x squared, I'm going to use the power rule. So that's 2x. So my du is 2x dx. Right. So now I'm just going to see, do I have a 2x dx? Yes, I do. And I have my u to the third power. So I'm just going to rewrite this integral as 1 divided by u to the third du. And the way I got this was I knew that 2x dx could be substituted with du. So I've got them there. It would be like I took 1 over 1 plus x squared to the third times 2x dx. So when I do that, then the 2x dx is substituted with the du, and I have 1 over u to the third. All right, so now I have to think about integrating it. Well, we can't integrate when we have the expression as a denominator, so we have to make it a numerator. So using my negative exponent rule, that is the integral of u to the negative third power du. And now I just integrate it, add 1 to it. Negative 3 plus 1 is negative 2. And I multiply by the reciprocal, negative 1/2. And plus c. Okay. And now I'm just going to replace my u with what I originally had. Please don't forget to do this step. So I get negative 1/2 times 1 plus x squared. That's my u to the negative 2. And I can simplify this more so that I don't have a negative exponent. I can simplify it more to 1, negative 1 divided by 2, 1 plus x squared squared plus c. And that is our answer for the first one. Okay. All right, now let's take a look at the next one. This one has a radical. So that's where we're using the fractional exponents rule for these. When we have a radical without a number here, we know that it's automatically just a square root. So it's like we have it to the square root power. All right, so let's see. We're going to have u be the expression inside the radical. So u is equal to t squared plus 2. And I'm just going to find the derivative of that. So du with respect to t is 2t. And now I know that my du is 2t times dt. Okay. So when I go back and look at my problem, I see I have a 2t and a dt. The commutative property of multiplication tells us that those two can be pushed together or separated, and they still have the same effect on the rest of the equation. And now I'm just going to substitute u for my radical. So I get the integral of 2t the square root of u dt. And once again, I can substitute 2t and dt with du. So I get now the integral of the square root of u du. Okay. And I know the square root of something is the expression to the 1/2 power. So now I have the integral of u to the 1/2 du. So 1/2 plus 1 is 3/2, so I get u to the 3/2. I take the reciprocal, that's 2/3 plus c. And now I just put my u back in there. So I have now 2/3. Sorry, I'm having a hard time preventing my paper from moving. 2/3 of t squared plus 2 to the 3/2 plus c. And I'm finished. All right. So with some of the problems that you have in this packet, you are going to have to multiply and divide by a constant in order to get your correct value for du. Just bear that in mind. And if you have any questions, let me know.